Next we are going to see next conic, parabola. So conics general definition: the locus of a point which moves in a plane such that its distance from a fixed point and a fixed straight line not containing that fixed point, the straight line which is not containing that fixed point, right, are in a constant ratio is called conic. We already seen this this definition, the starting point for circle, right? So fixed line, so fixed point, moving point, right? So the distance, the fixed point S is called focus. This is called focus. The fixed straight line is called directrix. So the constant ratio, distance from the moving point P to the fixed point S, distance from the moving point P to the fixed line, that is PM. So SP by PM is equal to a constant, let it be E. The constant ratio E is called eccentricity of the conic. The straight line passes through the focus and perpendicular to the directrix is called the axis of the conics. This is axis. Here the locus, that is moving path, locus means moving path of the point. The P is moving, right? That moving path is called conic. So if E is equal to 1, the conic is called parabola. So if E lies between 0 and 1, the conic is called ellipse. If E is greater than 1, the constant value, right, the conic is called hyperbola. The general equation of the conic is, let S x1, y1 be the focus, Lx plus my plus n equal to 0 be the equation of the directrix L. Let E be the eccentricity. Let P x, y be any point. So we are going to find the path of, that is locus of that point P, that is called conic, right? Then the equation of the conic is ax square plus bxy plus cy square plus dx plus ey plus f equal to 0, where a is equal to 1 minus e square l square by l square plus m square, and b which is equal to 2l m e square by l square plus m square, and c which is equal to 1 minus e square m square by l square plus m square, and d which is equal to minus 2 into x1 plus e square lm by l square plus m square. E is equal to minus 2 into y1 minus e square mn l square by divided by l square plus m square, and f is equal to x1 square plus y1 square minus e square n square by l square plus m square, right? So we are going to see the proof of this. So given S focus, P is the moving point, and L is the latus rectum. So PM is the perpendicular distance from the point P to the directrix L. SP is the distance between the focus and the moving point. We know from the definition of conic, SP by PM is equal to E. That is equation number 1. SP using the distance formula, root of x minus x1 square plus y minus y1 square, right? That is equation number 2. PM is the perpendicular distance from the point Pxy to the line Lx plus My plus n equal to 0. So PM is equal to, using the perpendicular distance formula, Lx plus My plus n divided by root of L square plus m square. That is equation number 3. From 1 to 3, SP root of x minus x1 square plus y minus y1 square divided by PM Lx plus My plus n divided by root of L square plus m square equal to E, right? That is just to do the cross multiplication. So root of x minus x1 the whole square plus y minus y1 the whole square is equal to E into the denominator of the left hand side, Lx plus My plus n divided by root of L square plus m square. So that implies, so in the right hand side you are having the denominator, right? In denominator you are having root of L square plus m square, just to do the cross multiplication with the left hand side term. So you will get root of x minus x1 the whole square plus y minus y1 the whole square into root of L square plus m square equal to E into Lx plus my plus n. Now squaring both sides. So we have to remove the root, square root, right? Then only we can easily simplify. That is why we are squaring whenever we are getting square roots, right? So squaring both sides, so square root will go. So remaining term x minus x1 square plus y minus y1 square into L square plus m square, because we are when we are squaring, the square root will go, right, for the both terms on the left hand side, right, which is equal to squaring on the right hand side e square Lx plus my plus n the whole square. So using a minus b whole square formula, right, x square plus x1 square minus 2x x1. For the second term also you are using the same. So y square plus y1 square minus 2y y1, right, into L square plus m square, which is equal to e square. So again using a plus b plus c whole square. So a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right, L square x square plus m square y square plus n square plus 2lmxy plus 2lnx plus 2mny. So just to do the multiply L square m square with each term on the left hand side. So x square into L square plus m square, first term. Then second term L square m square into x1 square. Third term minus 2 L square m square into x1, right? And plus L square m square into y square plus L square m square into y1 square minus 2 L square m square into y1 on the left hand side, right? Which is equal to, so we are taking the whole term on the right hand side to the left hand side. So put minus e square into L square x square plus m square y square plus n square plus 2lmxy plus 2lnx plus 2mny, which is equal to 0. So L square plus m square into x square plus L square m square into x1 square minus 2 L square plus m square into x1 plus L square plus m square into y square plus L square m square into y1 square minus 2 L square plus m square into y1 multiply with minus e square to each term, minus e square L square x square minus e square m square y square minus e square n square minus 2 e square lx my minus 2 e square ln x minus 2 e square mn y equal to 0. Divide the whole equation by L square plus m square, right? So divided by the L square m square. L square m square in the numerator divided by L square m square get cancelled. So you will get the remaining terms on the first 6 terms, right? X square plus x1 square minus 2x x1 plus y square plus y1 square minus 2y y1 minus then divided by L square plus m square. E square L square, right, by L square m square x square, E square m square L square divided by L square plus m square y square, then next term, then etc etc, then last term minus 2 e square mn by L square m square plus y equal to 0, right? So we are grouping x square term. So x square term, first term and the sixth term, right? So 1 minus e square L square by L square plus m square into x square. Then xy term minus 2 e square lm by L square plus m square xy. Then grouping the y square term 1 minus e square plus m square by L square plus m square into y square. Then x term minus 2 x1 plus e square ln by L square plus m square into x. Then y term minus 2 into y1 minus e square mn by L square plus m square into y. Then remaining terms x1 square plus y1 square minus e square n square by L square plus m square equal to 0. So this is in the form of ax square plus bxy plus cy square plus dx plus ey plus f equal to 0, where a is the coefficient of x square 1 minus e square L square by L square plus m square, and c is the coefficient of y square 1 minus e square m square by L square plus m square, and b is the coefficient of xy minus 2 e square lm by L square plus m square, and d is the coefficient of x minus 2 x1 plus e square ln by L square plus m square. E is the coefficient of y, minus 2 y1 minus e square mn by L square plus m square, and f is the constant term without xy terms, right? X1 square plus y1 square minus minus e square n square by L square plus m square, which is to be proved. Now taking b square minus 4ac. So b square is minus, so substituting the value, right? We know a value of BAC minus 2 e square lm by L square plus m square the whole square minus 4 into a 1 minus e square L square by L square plus m square into c 1 minus e square m square by L square plus m square. So squaring 4 e power 4 L square m square by L square plus m square the whole square minus 4 into, just to do the multiplication, 1 into 1 1 into e square minus e square L square by L square plus m square, right? Then 1 into minus e square m square by L square plus m square, then minus into minus plus e square into e square e power 4 L square m square divided by L square plus m square the whole square, then which is equal to, right, 4 e power 4 L square m square by L square plus m square the whole square, right? Minus, multiply with minus, minus 4 plus minus 4 into next term minus into minus plus 4 e square L square by L square plus m square, again plus 4 into e square m square by L square plus m square, then minus, right, 4 e power 4 L square m square by L square plus m square the whole square. The first term and last term get cancelled, right? So remaining you are having minus 4 plus 4 e square L square by L square plus m square plus 4 e square m square by L square plus m square. Taking 4 common outside, so remaining term minus 1. The next two terms e square is common, right? Take it outside, L square plus m square by L square plus m square, right? So it can be written as 4 into e square into L square plus m square by L square plus m square minus 1. So L square plus m square in the numerator and denominator get cancelled. So remaining you will get 4 into e square minus 1. So b square minus 4ac is equal to 4 into e square minus 1. That is equation number 3. Case 1. If b square minus 4ac is equal to 0, so 3 if and only if 4 e square minus c minus 1 equal to 0. So e square minus 1 equal to 0 if and only if e square equal to 1, if and only if e is 1. This if and only if the conic is parabola. Case 2. If b square minus 4ac is less than 0, so 3 if and only if 4 into e square minus 1 less than 0, if and only if e square minus 1 less than 0. So if and only if e square is less than 1, so e lies between 0 and plus 1, right? So this implies the conic is ellipse. Case 3, right? If b square minus 4ac is greater than 0, so 3 if and only if 4 into e square minus 1 is greater than 0, if and only if e square minus 1 greater than 0, so e square is greater than 0, so e is greater than 0, right? So this implies the conic is hyperbola. So these are all the general concept, right? Thanks.